Hello, everybody. Welcome to this Linaro Connect session 2021. It's a bit of an odd experience to do this remotely, so pardon me for any hiccups on technology or infrastructure or timing, but I'll do the best I can. So let's get started. My name is Alexander Zack. I'm one of the co-founders of Pentacore. In Pentacore, we invest in core Linux technology, tooling, and practices that we feel are necessary to help the Linux embedded ecosystem to take the next step, to get out of a world where binary firmwares that are statically deployed get replaced by something more agile, something that allows everyone from the app developer to the kernel developer to interact and use the system in a more convenient manner. And as a matter of fact, we have recently released our open source product for that, Pentavisor.io, so check that out. One of the things that is important if you talk about whether the embedded ecosystem is well served by the distributions or not is to take a look what distributions are, why they were made, and what they were not made to do. And for that, going back in history on Linux helps a lot, I think. So you can imagine at the beginning, just the Linux kernel existed. Nobody could use that thing out together, right? Then in the end, the Linux kernel got some packaging, so-called initial distributions, Slackware, Red Hat, Debian, and you name it. They actually made it very convenient to consume Linux, and it also gave us a clue that Linux is actually a great replacement for what existed at that point in the Unix server ecosystem on the enterprise space. And that was exactly the first commercial avenue that Linux would be taking. Distributions like Red Hat and SUSE would be strong in going in that direction, but there would also be others that tried to use Linux and the vast amount of components out in the field to build an amazing desktop that would compete against the monopoly of Microsoft back then. This really worked well. Developers across the globe came together, usually on an unpaid basis, to bring together great distributions that were amazing to use compared to what existed on the proprietary space. In Debian, you can apt install whatever from the repository, you can remove it, you can upgrade it, and all that feels very safe and very reliable. And on top of that, there were no stories about viruses and hackers floating around. So Linux became the synonym of amazing products that could arise from a community, a viral community that comes together to achieve a common goal. In the 2000s, this actually accelerated quite a lot. Distributions came out from all corners for all kinds of users and huge communities built around it. Distrowatch.com is something that you could have seen as the mirror of innovation, I would call it back then, that allows you to take a glimpse of how much enthusiasm and how much energy people put into making the perfect distribution. Myself, being in the distribution business from early 2000s, realized at some point that this is all great, and it's amazing how you can build a huge repository of software that you can then pick and choose from and install from, but that there is one big challenge to that approach, and that is, how can you go the next step? How can you be more inclusive for third-party developers to develop and distribute applications, so-called ISVs for such distributions and products, but also how could they go and make their derived distributions in an easy manner without having to invest in huge built infrastructure and use practices and huge engineering teams. And while doing this, more and time went by, I found out that no such thing really existed. This became even more obvious when we saw the arrival of the cloud. AWS gave you the ability to not directly interface with a server that you preciously owned, but you could just spin them up and scale them out as much as you wanted. And you could deploy software on it. And initially, the software would be complete images that you would pick, either Debian raw, and then you would fiddle around and install what you wanted, so on. But that also did not scale as much as it needed to be. Luckily, container and namespaces and zero technology evolved and Docker arrived. Docker gave now everybody the ability to not having to integrate into those distributions, to not having to pick the exact library versions that were already there, to not have to adhere to the policies that made it so hard for third parties to really effectively change and influence and make a distribution work in the way they wanted. Docker allowed you to do whatever. You were able to package a whole thing in a unit that you could then deploy in the field in a virtual environment. And that caused it became obvious that in the end, the host operating system would be less and less important to run this. The only thing it actually mattered on the host operating system is, of course, the Linux kernel. The Linux kernel is and stays and will be for the foreseeable future the common and most important piece of the Linux puzzle, obviously, even if people on the distribution side do not think this way. I think this is obvious, and especially on the cloud, you can see it. The only thing in a container that you care about is what kernel are you running on? Does it have all the features you need? Do people give me the powers to do this there? Containers went even one step further because you didn't need the host operating system that much anymore. They got rid of that host operating system as an intermediate layer you interact with altogether. Kubernetes is the word. With Kubernetes, you do not interact with the host operating system anymore. The time when users would SSH into a computer to install software was simply over. You would just use APIs and deploy the payloads you wanted to do. In those applications, they were not small fiddly components, but they were larger building blocks that in itself were testable and completely verified. They worked well in the way they wanted. And the only thing they relied on was APIs that went over the wire through the networking to talk to other components out there. Now, what happened at the same time on the embedded side? That is the thing that is the most interesting question for this talk, because in the end, there was not much of such an evolution to be seen. Of course, embedded Linux was an obvious thing to do. Controllers were not able to run anything sophisticated enough to make a good router, to make a robot, and so on. So making Linux firmwares was one of the important things that people wanted to do, and they started doing it. And this is exactly what they did. They copied the way of working from microcontrollers and tried to apply it to Linux. And no real distributions arrived that were useful for anybody who wanted to build a product. Yes, there's Buildroot. Yes, there's Yocto, which is, by the way, super complicated and super hard to untangle if you just want to take a small piece out of it. And it also is very opinionated and hard to pick and choose exactly the library versions you want to. So it's not very good for third parties that just want to get the job done. Android had shown it. I mean, but Android never really used anything from the distribution ecosystem. They built their whole system by themselves from the ground up. But no one that is a small startup and it's not Google can do that very easy these days. So there needs to be something. And we believe now 2020 has started and we are still on the embedded world back in the early 2000s from the way of working with those systems and developing it, that there needs to be the arrival of a new architecture that will center around a deployed platform like we have seen with Kubernetes in the cloud. Taking a step back just for a funny picture to show you, but also to show that this is really something that was really huge. I mean, the distributions, they're about making something that allows you to interact with the host platform. And that use case was very valid, right? Everybody had their opinion and you still use them on your desktop and you develop it. But for embedded products, they do not matter that much. Instead, in the cloud, what happened is that Linux, and especially distributions, they are not even mentioned in an architecture picture like this. The cloud native architecture just has Kubernetes, and on top you run all those components in containers that in itself are black boxes. You do not know which distribution Zookeeper or Redis has used in their container to put it together. It might be an Alpine, it might be a Debian, but in the end, it doesn't matter much, except maybe for size, what they are using. It is all about giving people the ability to quickly deploy the software stack they want to use, the applications, and having a way to connect those pieces together and have them orchestrated to produce a larger application altogether. And at the same time, in embedded, that's what you still have, right? This is 2020. And when you go and talk to any embedded developers, embedded Linux developers, that's for them, they work on a binary firmware block Somebody tells them what features need to be in there, then they work hard to do that. At some point, there pops out a firmware that, yes, will do those features, but then you can flash it like this. Right? That's it. There's no way you can, after the fact, after the market, easily add features. There's no way you can get third parties to effectively integrate into this without having to go through a huge bottleneck of the firmware team. It just simply does not work. So in order to get out of this kind of bottom standard of what embedded Linux and the practices they currently use, we think we have to rethink the way that embedded Linux is done and how the system is architectured. And this is the proposal I would like to present here in this session. I call it the universal embedded Linux system. So why is this universal? And why are others that are using containers not universal? I can tell you that. In our mind, the host OS should be as minimal and as unopinionated as possible. In fact, it should do nothing but operating the lifecycle of those containers, mediating access to the hardware devices, and offering protocol to really drive the deployment of such a system forward. In order to deploy something, however, you have to have a system that you can describe in a single transactional unit like this. And this is why this model is so great. You can define all the components you have in this picture in a single deployable, transactionally deployable actually unit that you can then drive to the system over a deploy platform into it. In this picture, the deploy platform must be unopinionated, also it's already mentioned, but also all the heavy lifting should not happen there. Nothing should happen there except the deployment and the lifecycle. The rest is the middleware containers. The rest is the system containers. The rest is the application containers and the management protocol containers for the higher level management tooling you would like this system to be driven through. All those can be done in containers, and all those should be done in containers because that's the only way how it can become really universal. Think about it. If you now decide and replace the immutable deploy platform with a Yocto host OS, you already lost half of the potential use cases there because people might not like Yocto. They might like more OpenWRT or the Broadcom SDK or Qualcomm SDK. They might have something completely custom. And if they want to make a special middleware, why do you want to force them to learn about Yocto and bring that into that ecosystem if there is not much value of having it in there? Similar, if you go for Yocto as a host operating system, you will not be able to distribute the Linux kernel and drivers in an independent manner. So people that do not want to use Yocto, they will not be able to benefit from any investment that happens on those BSP that's out there. So and this is the real trick of it. How can we make the bottom layer here, the Linux kernel drivers and the init RAMFS that is built into the Linux kernel, so small and so tiny that it's really useful and universal for everyone. And that's where we believe we have, Splinterwise.io, brought in a good piece that shows how it could be done, but we are open for discussion, and I would love to see opinions how this can be done in a minimal manner. But we cannot do everything. We need middleware containers that are smart, that are good, that have good standardized protocols so that somebody can take that and build an application-enabled system around it. And we need good management protocol containers that give you the ability to connect this to legacy management servers, like TR69 that is used in the telco ecosystem, or Kubernetes, maybe how you can integrate this into a Kubernetes management landscape that people would like to do. This is what you can do in a container. You do not need to have these kind of protocols and knowledges inside of the host OS platform, because that can all go into a container in this architecture. Now, let's sum up. What is really needed for the embedded happiness? Just to give you also some ideas on what we think the Linux community and Linaro in particular could do to make this world better. First, if you have everything in a container, it means that the host OS does not do the middleware anymore. It is not the one that abstracts for you the kernel and does all the dirty fiddling about how you assign resources from the kernel to containers anymore, or completely hide that fact. So we need to think and revisit, in our opinion, the topic of Linux device namespaces. What does it mean? How can I assign a certain type of hardware into a container conveniently? How can I bring, let's say, the graphics GPU card into the container for that does a Western container or an X11 container? How do I do this? I mean, yes, if I have a host OS and I can hack around, I can write that logic there, but why can we not do this just from the kernel primitive side of view using namespaces in particular? The other topic is maybe that's just a bug, right? I mean, but if we just put everything in a container, we always have challenges with loading modules, firmwares. Basically, all the user modes handlers that Linux is providing are not namespace aware. So let's fix that. Let's allow us to, if you load a module from a namespace, that it looks inside the namespace for that module. If you want to load a firmware, do that as well, right? Should be simple. I mean, tell me if not. Happy to have a discussion with you guys. And the last thing, and there are more things to do, but the last very important and fundamental thing that is at my heart here is to really find a solution to replace dbus. I mean, every system that is composed in the way I've just mentioned, with middleware and so on, they need a way that those components can talk to each other, that those components can be discovered, that can be connected, that they can exchange file descriptors and so on. And currently, the only answer for that is really on using dbus always in the setup. And dbus is not even great. Dbus is not ready for container world. It is not allowing you, for instance, to activate services inside a container that is offering that. Maybe due to similar problem like the user mode handlers, that they assume that everything that needs activated is running in the same container. Why would it be so difficult that the kernel to offer at least a way, if not a complete dbus type of thing in the kernel, to offer discovery and at least activation through the Linux kernel? This would be magnificent. It would help us a lot to get rid of dbus in this universal embedded system and still make it useful and standardized. And then besides Linux, and that's mostly on us and maybe a community outside of Linaro, obviously we need to agree on a standard packaging format for Linux BSPs and containers. So for BSPs and containers, maybe it's fit images wrapped with a certain metadata information that then can be handled in the same way as a container and so on. But let's take a look at it. We have proposed something with Panda.io that is one way to do it, but we're happy to talk and look what others are thinking and adjust accordingly. And the other one is that we need to truly open source deploy platform that allows to make systems out of such BSP and container packages. And what I mean by this is really getting a real, truly open source deploy platform. I have not seen that elsewhere than with Panda.io. Everything else is usually only half of the game. There's nobody who is offering also a cloud side add-on that is open source, that does all the amazing features there. There's no one who has a truly universal approach that is open to updating the kernel, updating containers in transactional units so that you are sure you know what you're running. And last but not least, I mentioned we need these product grade middlewares designed for container usage in mind. So let's get going and let's do it. I hope this talk was a good inspiration for you. I know I went a bit fast, but the time is really constrained here in this session. Let's have some discussions offline and for the rest of this session in the channel. But you can also find us on Panda.io or use the email I've shown you before. Thanks for listening and talk to you soon. Stay safe.